Hello, we are back. We're going to be talking about evaluating and graphing simple exponential functions. Before we do that, we need to talk about negative exponents and make sure we remember what that means. Now, of course, we remember that if we had something like, 2 squared, that means 2 times 2, that's 4. 2 cubed, 2 times 2 times 2, 4 times 2, that's 8, right? 2 to the 4th would thus be 16, right? You can see the pattern here. Each time we're multiplying by 2, because we're adding another times 2. No big deal. So going backwards, that means that 2 to the 1st, right, is just 2. There's not 2 terms, so there you go. Now, you can see that, you can see that going down here the pattern is times 2. Going up the pattern would thus be divide by 2, right? So 2 divided by 2 is 1. So that's what 2 to the 0 has to be, right? Is 1. Okay? And then 2 to the negative 1, if we do 1 divided by 2, 2 to the negative 1 has to be 1/2. Right? Okay, and I don't have room up here, but then 2 to the negative 2, this divided by 2 would thus be 1/4. Okay? And the way that we remember this, the way that we show this, is because 2 to the negative 2 is the same thing as 1 over 2 to the positive 2. Okay? So you'll notice that the negative exponents and the positive exponents, if they're the same exponent, are the same thing except just reciprocals. Alright, so let me show you what that means. We go down a little bit. So if we have 3 to the 1st, 3 squared, 3 cubed, 3 to the 4th, right? So 3 times 3 times 3, 3 times 3 times 3 times 3, 81, right? So then 3 to the 0, 3 to the negative 1, 3 to the negative 2, 3 to the negative 3, I'm not going to have room for 3 to the negative 4, but anything to the 0 is 1. 3 to the negative 1 is 1 over 3. 3 to the negative 2 is 1 over 3 squared, so it's 1 over 9. 3 to the negative 3 is going to be 1 over 27. You can see 3 to the negative 3 is related to 3 to the positive 3. 3 to the positive 3 is 27. 3 to the negative 3 is 1 over 27. So if we have 3 to the 4th is 81, 3 to the negative 4th would then be what? What do you think that would be? 1 over 81, right? So if I told you that 2 to the 9th is 512, 2 to the negative 9th would be what? Be 1 over 512, right? And notice that we can have negative, really big number here, and this is never going to be a negative number, okay? Raising to a negative power never makes it negative. Okay, so that's something really important to remember. Now we're going to evaluate some exponential functions here. Once I can get my computer to work here. Okay, so if we had something that looked like this, f of x equals 2 to the x, and I wanted to find f of 3. Okay, remember that we just plug this in right there, okay? So we just say f of 3 equals 2 to the 3rd. Of course, 2 times 2 times 3 is 8. No big deal, right? So if we wanted to find f of negative 4, what would that look like? f of negative 4 is 2 to the negative 4, right? So that's 1 over 2 to the positive 4. So that's 1/16. Okay? Alright, now, do you think you would be able to... Why is this not working here? You think you would be able to, if I said f of x equals 2 to the x minus 2 times f of negative 2. Go ahead and pause and try to figure that one out. Pause the video. Okay, you should be back here. Check your work. This is going to be 3 to the negative 2 minus 2, which is the same thing as 1 over 3 squared minus 2, which is the same thing as 1/9 minus 2. Oh, and then there's fractions. Oh boy. I would love to be able to scroll down. Why can't I scroll down? So, 1/9 minus 2. What we have to do is turn it into 2 over 1, find a common denominator. Or you can, if you have access to a calculator, you can do it that way as well. In this case, it's negative 17 over 9. Okay? So that's evaluating exponential functions. And now we're going to be graphing simple exponential functions. Okay? So, let's take a look at how that looks like here. There's our graphs. Alrighty, so I found my graph here. We're going to be graphing y equals 2 to the x. Okay? To the x. What we need to do is create a table of values and see what that looks like. We're going to put in a lot of values because it's kind of a funny looking graph if you haven't seen it before. So this here is 2 to the third, so that's 8. This is 2 squared, so that's 4. This is 2 to the first, so that's 2. 2 to the 0 is 1. Remember this pattern from earlier. 2 to the negative 1 is 1 over 2. 2 to the negative 2 is 1 over 4, so then this is 1 over 8. Okay, so we're going to go ahead and graph it. We're going to start down here before we get into the fractions. 3 comma 8, so this is 3 comma 8, right there. 2 comma 4. So each one of these is a coordinate 8, right? Okay, 2 comma 4. 1 comma 2, 0 comma 1. So you can see it's kind of coming down here. Okay, negative 1 comma a half. So we go negative 1 and then a half. Negative 2 a fourth. It's going to be like right there. Come on. There we go. Negative 3 an eighth. It's going to almost be on the axis there. Okay, so what happens here when we connect them is it gets closer and closer to the x-axis, but it never, ever reaches it. So close, never reaches it. Okay, this is an exponential curve. This x-axis here is called an asymptote. Okay, I'll label that. So, the x-axis, okay, this is the asymptote. And that's, in this case, along the x-axis. And the equation for that is y equals 0. Alright, so that's an asymptote. Okay? Now, go ahead and see if you can, I'm going to have you can draw y equals 3 to the x. Y equals 3 to the x. Okay? Y equals 3 to the x. Pause and see if you can draw that. Okay, so y equals 3 to the x. These should be pretty straightforward. Remember, 3 to the 0 is 1. 3 to the negative 1 is 1. This would be 1/9. This is 1 over 27. We'll graph that on here. 3, 27, can't do it, it's off the graph. 2, 9, right there. 1, 3, 0, 1. They both go through that point. And then it's going to be a little bit lower. Okay, and at that point, it pretty much looks like the other one, right? So to the right of the y-axis, it's steeper. To the left, it's actually just approaches the asymptote that much sooner. Okay, now we're going to try one other where it gets a little bit more complicated, but not much. Okay, we're going to try y equals 4 to the negative x minus 1. Okay, same thing where we do these same x values. Okay, now over here we have 4 to the negative 3 minus 1. So that's the same thing as 1 over 4 cubed minus 1. Right? So 4 cubed is 64. So we have 1 over 64 minus 1. So if you do a common denominator there, that's actually negative 63 over 4. Over 64, excuse me. Negative 63 over 64. Okay. You do the same thing for 2 here. Okay, and we have 4 to the negative 2 minus 1. So that's 1 over 16 minus 1. So that's negative 15 over 16. 4 to the negative 1 is 1/4. So this is minus 1 is negative 3 over 4. 4 to the 0 minus 1. 4 to the 0 is 1. 1 minus 1 is 0. This is 4 to the negative 1. But remember, that's negative 1. Negative 1 would just be 1. So it's for the first. This one is 4 to the negative 2. So that's 4 squared, which is 16. This is going to be 64. You see these patterns, right? Oops, I made a mistake. Did you catch my mistake? Made a little mistake. This is 4, but I forgot to minus the 1. So 4 minus 1 is 3. 16 minus 1 is 15. 64 minus 1 is 63. So we're going to try to graph this. This gets a little crazy. Exponential graphs go off, get really big really quickly. So this one's going to be off the charts. This one's even off the charts. Negative 215 is way up there. Negative 1, 3 is right there. Goes through 0, 0. 1, negative 3/4, 2, negative 15 or 16, 3, just about right there. So you can see that our asymptote at this point is negative 1. It was on the x-axis before because it's like a plus 0. Here, it's like this has a plus 0, which is why we have the asymptote there. Okay, this is the asymptote, whatever the constant is at the end. But with this one, we have a minus 1. So the asymptote is at negative 1. Y equals negative 1 is the asymptote. So we're going to connect our graph here. And it looks like that. Okay? So notice that when we have a negative exponent, it decreases and then approaches the asymptote. Okay, whereas the positive exponent, it increases. So positive exponent, positive x there, it increases. Here's a positive